Hello. So today I am recording for you a lecture basically in order to explain the milestone, the third milestone. And before explaining more in details the third milestone, I will cover the explanation of liquid crystal display LCD more in details as an output display and the RGB light emitting diode, and the two displays, which are the RGB LED and the LCD, will be used with the milestone. So it's more, I want to explain the idea behind the LCD, how it works, and how we can interface it with the Arduino. So as there are many varieties of solids and liquids, there are also many variety of liquid crystal substances. And liquid crystals, basically, the important specification is that depending on the temperature and particular nature of the substance, these liquid crystals can take several distinct phases. I will not go into physical chemistry here, of course, but I just want to spend 2 slides in order to explain for you how a pixel inside the LCD will go dark or it will go light. So there is a phase in the liquid crystals. It's called nematic phase, and this nematic phase, it is when the molecules are aligned with respect to the longest or largest axis of the molecule. So when they are in this phase, what is important is that they can be twisted based on a certain electrical current. So when we apply this electrical current to these liquid crystals, we will untwist them to different degrees depending on the applied current. And this is where all the idea of LCD comes from. So this idea comes from that when these typical liquid crystals behave with different amount of electric current, therefore, if these are twisted, so there is no current, the light is then aligned and outside light is reflecting back. So the pixel now is off, but in fact it is bright because it is reflecting all the current from the outside world. However, when there is current, that's reflecting the light from the outside world. When there is current passing through this, these liquid crystals will be untwisted. Therefore, the light will not be reflected anymore and it cannot go out of the display. So I can say that this pixel is on, therefore it is dark. So in this way, we may pass some currents in pixels to make them dark, so to make them on. And by doing a good combination of these currents, we will create some characters, letters, and numbers. Okay, so now the idea is that they are often reflective, as we said, but maybe there is not sufficient outside light in order to have a good reading. This is why most of the LCD are built in with fluorescent tubes behind the LCD in order to have this is what we call a backlit LCD. Okay, so in this way, I will ensure a more uniform display even with different light conditions in the outside environment. There is a very large variety of shapes and sizes. Basically, it was seen on the output display lecture, but they are classified with respect to what is the number of characters inside each line and how many lines each LCD. Okay, so here is the problem, is that communicating from a microcontroller directly to an LCD is not easy, okay? Because every pixel, and we will see later on that every character has around 40 pixels, and every pixel should have a current. So really, it's not very easy. So this is why in the back of the LCD, in fact, there is what we call a driver. And this driver will, so as I said, it's a hectic task to handle everything. So we need a driver. So it's an integrated circuit. For example, the Hitachi HD44780, this is the most used interface driver. If not this one, most of the other drivers behave as the Hitachi HD44780. Okay, so this is the one who manages, in fact, everything with respect to the LCD. I will give you a very small example here. So as you can see, for example, if I want to write the letter A with an underline beneath it, okay, I will send the letter A here. So the driver will know that what are the pixels for this letter, okay, and it has 8 and 40 segments. So, and the intersection will create these pixels. So it's really complicated to work with the LCD per se. However, it will be easier for us to work with the driver, and this is what we will do. The LCD in the Tinkercad is a 16-character, 2-row, and it is based on the Hitachi HD44780 driver. Okay, it has a 16 pins output, okay, as we see them here, okay, and I will explain the now the pin out of each one of these pins, okay, also based on the HD44780. So the first one is a ground, and the second, the pin 2, is VDD. Generally, it's +5. We can go to 6, 4.4, 3 volt can work a little bit, okay? But basically and typically it's 5. So 1 and 2 are in order for the power supply of the LCD. Pin 3 is a contrast pin, okay? So it should be a voltage here, and this is where a contrast will, so the contrast is in fact the difference between dark and light, okay? So the maximum contrast is when this pin is grounded, so it is connected to ground. However, typically we connect this to a potentiometer to create a certain voltage divider, okay? And by changing this potentiometer, I am changing the contrast of the LCD. Pin 4 is RS, or what we call register select. So this is something very important to start here and to understand it well. We should communicate with the LCD. The LCD is a kind of microcontroller, if you want. It has some registers in it, so some places in memory, okay? But I should, for example, tell, and this is what we'll see a little bit later on, I should tell the LCD where the cursor should be. I should tell the LCD if I want to start writing on the first line or on the second line. I should tell the LCD if I want the cursor to be blink or no blink. Or I should tell the LCD what are the type of characters that I should print. So I should have, there is a part of programming. So this register select, okay, will tell the LCD if it is low, okay, if it is low, so it's 0, data types transferred to the display are treated as comments. So everything I send to the LCD will be comments, so it will be like programming, okay? However, when this RS is high, so +5 in this case, so the data I send to the LCD are data, okay, are not comments. For example, is the A, is the letter B, is the letter C, okay? So this RS is very important in order to check if the data I'm sending, or the bytes I'm sending, and we'll see now this, are command for programming or pure data. 6 is the enable. Okay, so it's here it's the difference is because I started with pin 0 there. So pin 5 is read, no, I'm good. So pin 5 is the read write. This line is low when I want to write on the LCD, and it is high when I want to read from it. Generally, I don't read from the registers of the LCD, I read from the LCD itself. So this is why here, generally, I put ground here because I always write data on LCD. 6 is the enable line, okay? And this enable line will initiate the actual transfer of commands, and we will see that every time I want to send a command, okay, the enable line here should go from high to low. Whenever there is a falling edge of this E, the signal is transmitted to the LCD. Okay, so this is here in order to have all the signal transmitted to be synchronized. Okay, next, here I have pins 7 to 14. These are 8 pins to transfer data or program. So or commands, I mean, if register is low, the data sent here will be commands or programming. When the register select is high, the data here will be the characters. Okay? As you can see, it is a large number of data, and if I have, or wires here, so if I have one Arduino, okay, so here I need at least 1, 2, 3, and 4, and 8, 14 pins, so I took all the input-output, digital input-output pins of the Arduino. So this is why always the LCD gives me the opportunity to send this 8-bit all in one packet, or I can send them as 4-bit at a time. So I will use the lower this, okay? I will use these 4 bits. So the 8 bits will be sent 4, then 4. In this way, I will be using here in this case just 4 digital input-output from the Arduino, not the 8. Okay, and this is the most used method in order not to take all of the digital input-output of the microcontroller. Okay, so this is what I said here. So it's very beneficial because fewer input-output microcontroller lines are required. The last two, they are if you have a backlit LCD, which is most of the case, this is where you will give the power to the backlight in order for this LCD to backlit. Pay attention, 16 will be connected to ground and 15 will be connected to a voltage supply, which is typically 5 volt. However, do not forget the limiting current resistance, which is 100 to 200 ohm, never connected directly to the source. It's a very simple LED that is behind this LCD. The next slide will show you how the LCD is connected to an Arduino. Okay, as you can see, this is ground. Okay, this is plus VCC. This is for the contrast connected to a voltage divider by a potentiometer. Typically 1K 500 ohm is a good potentiometer. This is the register select connected to one pin. This is the enable connected to another pin. The read-write is low because I'm always writing on the LCD. I don't want to read from it, from the register in fact. And these are the 4 pins connected to the 4 digital input-output. So here I'm taking 6 digital input-outputs. It's not 10, okay, because I'm using the 4-bit. Then you have the LED plus is connected through a current limiting resistor to the positive power supply, and LED minus to ground. This is the best way to connect it. Okay, so therefore, if I want to program the LCD, what should I do? And if I need to program the LCD, I will put RS here, okay, to low, and then I will send commands via these 4 bits, okay, and these commands are the following. Clear display screen, I should send 01. Return home as cursor, 02. Display on, cursor off. Display on, cursor blinking. Shift the entire display to the right, etc., etc., etc. I will take one example. Let's take this example, which is display on, cursor blinking. So what should I do? Look at the steps that should be done. 1, I should enable and set a blinking first. First I should send 0F through the data line. That should ensure that register select is low, because it is a command, it's not data. I should ensure that RW is low, and then I should have a falling edge on pin E. So it's not very easy just to have one blinking cursor. Okay, I will tell you now how can we solve all these issues with Arduino. Then if I want to send the character A, what should I do? Set the register select to high, because it's a data now, it's not a program. Then ensure RW to low to write data. Then send 41 through D0, D7. This is the ASCII code for A. Then make sure that I have a falling edge of E in order for this data to be sent there. Okay? So this is for 2 ways, how to send commands and how to send data. You can have something else also. I will not quote it in details about this, but just to show you the large capabilities of one LCD. Okay, so you have commands between 40 and 64 hexadecimal. These are what we call custom graphics random access memory. Okay, so this is they let you in fact create any graphic you want. For example, I want to create a robot graphics as one character inside this LCD. This is how I do this. Okay, maybe someone can see it a child, I see it a robot, but this is how can I do it. It is every character is 5 rows, 5 columns, 8 rows. So what I will do, I will create I told you between 40 and 64, so I can create around 8 different characters, custom characters. So what I do is 0. Okay, so I will send 0E here in order to get this. So it's 0, 1, 1, 1, 0. Then 1, 0, 0, 0, 1. Then, so I will send one after the other, after the other, after the other, each one in this, okay, in order to create this graphics. Okay, I don't want to go into details, but here I just want to tell you that the CG RAM is a volatile memory, of course, and I want to tell you that you can create a custom graphics if you want. Okay, so this is how can I transfer data in 4-bit. So I will use only D4 and D7. D0 to D3 will be floating in general, so I do not connect anything on them. This is the same as I showed you how to connect it in Tinkercad. Okay, so I will send every bit in 2 halves. How to interface this LCD with Arduino? Fortunately, everything that I have discussed before is not applied in Arduino, because we're really working on high-level programming. So what I will do is I will add the Arduino library, Liquid Crystal. And this is a collection, as we saw in the lecture, it's a collection of functions that can help us to communicate with this LCD we will communicate at high level. Okay, we do not go into details as I showed you in the beginning of this lecture. You can check this link in order to see what are the functions inside this library. Here I put for you an example of these functions. Okay, so you just, this is for home in order to take the cursor home, etc., etc. I will give you an example about hello world. So look at how can I, if I want to print hello world on the LCD. So first I will include with a preprocessor directive the liquid crystal.h. I will include this LCD library. Then what is important for me is to tell the microcontroller what are the connections to the LCD. So here I am creating a variable, a liquid crystal variable called LCD, and I am saying that my register select is connected to 12, my enable is connected to 11, my 4 bits are connected to pin 5, 4, 3, and 2. By setting this syntax, I am telling the Arduino that these are the connections of my LCD, and since I did not put 8 here, I put only 4, I am telling the Arduino that I am using the 4-bit transfer. Okay, so this is how can we initialize the library and the LCD. Then I will begin with telling the Arduino what is the number of columns that I have inside my LCD and the number of rows. So this is 16.2, and I will put lcd.print hello world. So I will see hello world. Okay. If I want to see further the number of, for example, seconds from which the Arduino has reset. Okay, this is what I will do. If I want this number of seconds on the second row, so I will set the cursor to the first column, second row, because they are indexed with 0. So this is the first column, second row, and then I will say print millis. We talked inside the advanced Arduino software timing what are millis. So millis is a function that reads the hardware timer and return a number in milliseconds over 1000 in order to appear in seconds. So this is what we see at one instant. Whenever this will be run another time, hello world will stay as is, because this is in the setup and it is just once, and what I do is I change every time this number here. Okay, so this is an example about hello world, and in this way we finished the part covering the liquid crystal display. Now if I want to cover the RGB light emitting diode. So what is the RGB LED? The RGB LED is a combination of 3 different LEDs. One is output red, one will output a green, and the other one will output a blue. And you have here 4, since I have one common cathode or anode, we'll see. Why we use this? We use this as one package because, you know, from RGB I can create all the combination of colors that I want depending on the amount of brightness each LED will take. So there are 2 configurations of these RGB LEDs. The first configuration is called a common cathode configuration, where I have the cathode, which is the negative electrode, common to the 3. Therefore, if one of these should be on, I should send a 5 volt. And I have a common anode configuration, okay, where the common positive electrode is common, and if I want this LED to be on, I should send ground here, okay, in order for this R to be on. But as I told you, I do not want a full brightness for all, because if I have full brightness for all, if I send here 0, 0, and 0, the 3 will have full brightness, and this will be color white. Therefore, I should send duty cycles in every one of these LEDs. So, for example, duty cycle from 0 to 255, you know from the Arduino. So if I have, for example, this is 191, 127, 64, this is 25%, 50%, 75, and 100%. And these are some numbers, okay? So here the green, excuse me, here the green is 255, okay? However, the red and blue are 0, 0. Here, the combination of blue and green will give me different colors. Okay? How can I program this with Arduino? As simple as connecting 3 PWMs. So I will analog write on the pin connected to my red a value, and then I will analog a value from 0 to 255. Okay? And then I connect the green to another pin, and I write from value from 0 to 55, and the blue to another pin 0 to 255. Okay, so 0 correspond to 0 brightness, 255 correspond to maximum brightness. This is if I am using a common cathode configuration. However, if I am using a common anode configuration, the same applies. However, there is one point here that differs, is that 255 correspond to 0 brightness and 0 duty cycle correspond to maximum brightness. So the difference is that you put 255 minus the value in order to have this connection to the Arduino. Okay, so in this way I finished this. Then I will go to your milestone. Okay, and I will put it here in the screen. Okay, so it is due on Saturday on Tinkercad, Saturday, March 28th. So what you have first is you will use the TMP 36, okay, which is the only temperature sensor that is available on Tinkercad. And this temperature sensor is spans between -40 and 125 degrees centigrade. Okay, so in order to calibrate, first you have to calibrate the sensor. Okay, so to calibrate the sensor, you can connect it to a digital multimeter, and while running the simulation on Tinkercad, you can change the temperature. You simulate a temperature change, of course. So what I need is that you take 5 different values of temperature and the corresponding voltage output of them, okay? And then you will find the best fit line of the calibration curve. And then you compare this to the TMP 36 datasheet that I will attach to this milestone. So this is your calibration of the temperature sensor and a comparison with a datasheet. This is the first step of this milestone. The second step is the RGB LED. So now, since this temperature sensor is calibrated, I can know the temperature. Now I connect the RGB LED to my Arduino, and when the temperature is less than 0, it will give me a pink. When it is 0 to 39, it will give me yellow. 40 to 79, it will light green. 80 to 125, it will write red. Okay? Now, the third part of this milestone is the connection with the LCD output. So this LCD can output 2 things. And these 2 things will be dependent on a slide switch. So you put a slide switch with 2 positions, 1 and 2. When the switch is in position 1, the LCD will show the temperature with an auto scroll of the text. Okay, so the LCD will read temperature equal 80 C. And what I mean by auto scroll is that you see that you always see this in the roads. So you see this temperature like it is walking from left to right. Okay, this is what auto scroll. When the switch is in position 2, the LCD will not show the temperature. The LCD will show in the first light the color of the RGB LED. In the first line, it will show let color is, and in the second line, it will write what is the color: pink, green, yellow, and red, depending on the temperature that I have. Okay? What should you submit? You will submit, of course, based on the nickname I have sent you on the Tinkercad, the circuit and the code. Then you should email me a report, okay, including the calibration method, generally, as we have reports for our milestone, where most importantly you have to discuss your calibration and then maybe some challenges, okay, and then you copy the code and put it on the report. If you want, you can record a video and attach it to your report as a YouTube link or as a OneDrive file. Okay? I hope that this lecture is clear enough in order for you to start working on your milestone. Good luck.